Hello everyone, welcome back. Hopefully you had a good rest after that big test yesterday, and I hope you're all ready to go for today. What we're going to do today is just a little bit of quiz review. We're going to see an example, one more example of each type of method that we have learned up to this point, and then we're going to talk about something called gerrymandering. And it's the final topic that we have in Unit 2, Part 1. So I'm going to quickly give you an example of what it means to gerrymander something, and then we'll take our quiz tomorrow and hopefully do well. All right, so let's do a little bit of review here. So we're going to start by apportioning this small country that has 5 states, and we have their populations listed here. We are apportioning 89 seats, and we want to use each of the 4 methods. Right, so I'm going to go ahead and just start by filling in my table here. We're doing Webster first, so we're going to use Webster's method on this first one here, and we're going to fill in our populations. All right, so the first thing we're going to do once we get these populations filled in is we're going to determine our divisor. And the nice thing about the 4 methods is that determining the original divisor, the first divisor, is the same for each of the 4 methods. Right, I've got to take these 4 populations, I need to add them all up. Right, and if you do that correctly, you'll get 409,000 total people in this country. And then to find the divisor, we take the total population and we divide by the number of seats that we're apportioning, which is 89. So if we do that correctly, we should get a divisor of 49595. Oops. 4595. Let's turn it. 4595.505. 6. Let me just double check that number. I don't want to make any big mistakes here. Yeah, so 4595. So that's correct. All right, and then what we're going to do next is we're going to take that divisor and we're going to divide it into each of these individual populations to calculate our quotas. And luckily enough, that is also going to be the same for every single method. We'll do that first, right? So our quotas are going to be as follows, right? If I take 81,000 and divide by 4595.5056, we will get 17.6259. And then we'll repeat for the rest of the states here. All right, so I got my quotas, and now we're gonna follow Webster's instructions on what to do with those quotas. Remember, what Webster said to do was to take the quotas and round them based on 0.5, right? So if it's above 0.5, it's gonna round up to the next number. If it's below 0.5, it'll stay at that lower quota, right? So it will go down to that whole number there. Okay, so this one is a 0.6259. That's above 0.5. So this is going to go from 17 to 18. Okay. Now this one's a 10.22. That one is below 0.5, so this one will stay at 10. This is a 0.0391, so this one will stay at 40. And this one's at 21.1. That's below 0.5, so this one's going to stay at 21. Then we add up and we make sure that we have apportioned all 89 of our seats. And if we add these up, we will indeed get 89. So we got lucky. If we did not get 89 here, we would have to adjust our divisor, and then it would become a modified divisor, and we would have to keep modifying it until we found one that gave us the correct apportionment at the end. So our final divisor is actually our original divisor in this problem, which is going to be 4595.5056. So we'll use that divisor. We did not have to modify it for this one. We got lucky. All right. So like I said, the population and the calculation of the quotas are all going to be the same here, so I just copied those down, and this time we're going to use the Huntington-Hill method. All right, so remember, Huntington-Hill uses the geometric mean to round the quotas. So I have to go through and I have to calculate my geometric means. To do that, we start by taking the lower quota, which is 17, and what I call the upper quota, which is going to be 18. So 17 plus 1. Right, this will be 10 plus 1 is 11. This will be 40 plus 1, which is 41, and 21 plus 1, which is 22. And then to calculate the geometric mean, we simply multiply those two numbers and then take a square root. and we'll do that for each one. All right, so I'm gonna plug this into my calculator. And then once we have our geometric means here, we are going to round our quotas based on those geometric means. So if our quota is larger than the geometric mean, then we'll round up to the next number. If it is not, then we will keep it at the lower quota here. Okay, so 17.62 is more than 17.49, so this is going to round up to 18. 10.22 is less than, so this is going to stay at 10. 40.0391 is less than 40.49, so this one will stay at 40, and this one will stay at 21. And you'll notice that this is the exact same thing that we got with Webster, so this should add up to 89. And we got lucky again. We did not have to adjust our divisor, so we can just stick with the original divisor this time, which is 4595.5056. Now remember, you're not always going to get so lucky. Right, so if this were, if we ended up doing this apportionment and we got too many, like if we got 90, we would have to increase the divisor, but if we did not get enough, we would have to lower the divisor. All right, so you have to figure out which direction you're going. Right? We got lucky there again, we did not have to modify the divisor. All right, so the next method we're going to do is Hamilton's method, and again, populations are the same, quotas are the same, and Hamilton's method is really simple and straightforward, right? Just find the lower quota, right? So that's going to be all of these whole numbers here. So we're going to say 17, 10, 40, and 21, and then we add those up. And if you do, you should get 88. So that is not enough, but Hamilton had a very easy way to get the last seat apportioned, and that was to give the bonus seat or the leftover seat to the state that has the highest decimal portion, which is going to be state A here with their 0.6259. So the 17 will get bumped up to the 18, and the rest will stay the same. And again, you'll notice that this apportionment is the same as what we got in Huntington Hill and Webster's, so this will add up to 89, and this becomes our final apportionment. So far we see Webster, Huntington Hill, and Hamilton all getting the same exact apportionment. All three of those methods have agreed with each other so far. Okay. Now let's take a look at Jefferson's method. This is the last of the four that we need to talk about. Again, populations and calculating of the quotas all stay the same here. Right? But when we get to those quotas, what Jefferson said to do was to ignore the decimal parts. And so if I do that, what I'll get is 17, 10, 40, and 21, and if I add those up, we already know from Hamilton's method that we will get 88 seats apportioned. So that is not enough. So we are going to have to modify the divisor here to make that work. So remember, Jefferson didn't award the bonus to the highest decimal portion. Instead, what Jefferson did was he went back and said, let's just change the divisor so that when I get those lower quotas, I get the numbers that I need. Okay, so I'm going to lower the divisor. I'm going to try 4,500. Okay, so what I'm going to do is I'm going to split this column in half. I'm going to go through and recalculate my quotas based on this divisor, and I'll write those new quotas right here. And then I'll reapportion using that method. Okay. All right, so I've got my new quotas right here, and again, I got those by taking each individual population and dividing by my new modified divisor, which is 4,500, and then I'm going to come over here and I'm going to take the whole number parts from my new quotas and make that my final apportionment. So I've got 18, 10, 40, and 21, and if I add those together, I will get the 89 that I need. So you can see what we got originally, and then you can see what we got after we modified the divisor here, and you can see that extra seat ended up going to state A in this particular scenario. Okay, so my final divisor that I used here, right, what we would call the modified divisor or the final divisor, was 4,500. So we did have to change the divisor on Jefferson's method. All right, so that's a quick recap on the four different apportionment methods. We're going to talk about the last bit of content here in this particular unit, which is called gerrymandering. All right, so to give you a little bit of a setup, all right, on what happens here. So let's say we go through an apportionment process, okay? And after the apportionment, the federal government has decided to give the state of Illinois 18 representatives in the House. All right, so we now have 18 representatives, and each of those representatives need to represent a district inside of the state. All right, so these districts are the boundaries that we draw. It's like an area of the state, and inside of that area are people, and the people that live in those districts will vote for their representative. Okay, now how these districts are shaped and how they draw the borders and the boundaries of the districts is determined by the state Congress. Okay, so whoever is in control of the state Congress, whether it's Democrats or Republicans, essentially get to choose how to redraw those boundaries. And the act of drawing those boundaries to give yourself an advantage is called gerrymandering. Okay, so I want to give you an example of this with a very easy to look at state here. So if you read this, we're gonna gerrymander this thing so that we give Democrats a distinct advantage, and we have to create 5 districts. Okay, so let's say in our hypothetical state here, we have been apportioned 5 representatives, and we have our rectangular state here. And we know that in this part of the state, most people who live in this part of the state tend to vote Republican. So we would consider this like a Republican region of the state. Whereas in this rectangular region, most of the people are going to vote Democrat. Okay, so this is a Democratic region of the state. So we've got to create 5 districts. Each district has to have 4 voters, and it must be a continuous district, so I can't split my district into 2 separate areas. Right? It has to be one continuous district. Okay, so I want to draw the borders of my districts in such a way that Democrats end up having the most representatives in the House. Okay, so I'm going to draw a district here for you. So I'm going to go over here, and I'm going to draw the boundaries of my first district. I'm going to draw this boundary. Okay, so here is my first district, and I'll call this District 1. Okay, and if I look inside of this district, right, and I look at these regions here, right, this is going to vote Democrat, this is going to vote Democrat, this is going to vote Democrat, and this is going to vote Republican. So for this entire district, it is most likely that they will elect a Democratic representative. So if I come over here, right, and just kind of keep tabs on how many of my Congress people are going to end up being Democrats, I so far have created a district that will almost assuredly give me a Democratic congressman or congresswoman. Okay, so we have one for the Democrats. Now I'm going to draw a second district. Okay, and I'm going to come over here, and I'm going to draw the boundaries here. Maybe I should use a different color. Let's go green. And we'll draw a new boundary down here. So it's, you see my strategy here, right? I'm drawing my boundaries so that each district that I draw leans Democrat. That way I get a Democratic representative, right? So here we'll call this District 2, and I'm going to have 1, 2, 3 Democrats and 1 Republican. So this District 2 is most assuredly going to vote for a Democrat, right? So I will get another Democratic representative out of that district. So now I have 2 of the 5 will be Democrats for sure. I'm going to draw a third district. Let me get a different color going here. Let's go red, and I'm going to draw a third district. I'll draw another one over here. And I'm following the rules, right? These districts that I'm drawing have at least 4 voters, or 4 regions, and they are continuous. Okay, so this one, right, is going to be called District 3, and it is 3 Democrats to 1 Republican. So this one will give me a third Democratic representative. So now 3 out of the 5 representatives that I sent to Congress are most assuredly going to be Democrats. I still have to create 2 districts. So let's pick a different color here, and let's go, I don't know, let's go with orange. Okay. And I'll come over here and I'm going to draw a district. I'm going to draw a big district this time. So I'm going to draw this one like this. Make this one a big district. There we go. So there's my district. We'll call this District 4. And when I count this one up, I've got all Republicans and 1 Democrat. And you're probably thinking, well, that's not a Democratic advantage. That's okay. We can't win every single district, okay? So I'm going to give that district to the Republicans. They're going to get 1. All right, so I still have an advantage because I have 3 Democrats and 1 Republican, and I have 1 district left to draw. I have to draw 5 districts here, so I'm going to go here. Let's choose a black border this time, and my last district has to be these last 4 regions down here. And we'll call this District 5. And this one is going to be a toss-up, right? Because I have 2 Democrats and 2 Republicans. So this will be a very competitive district where they will be able to go back and forth and compete. So we'll give that one to the Republicans. We'll give them the benefit of the doubt and say, hey, let's say they get that last district. Well, the Democrats still have the advantage because they're going to get 3 automatic representatives to the Republicans 2. All right. And that is why the ability to draw those district boundaries is an extremely important source of power in our voting system, because you can draw the map to give yourself an advantage in terms of the number of representatives that you send to the House for your party. Gerrymandering is not illegal. You can draw the map however you see fit. If you look at the last part of the notes, you will see some obvious abuses of power when it comes to gerrymandering and drawing districts, and both parties do it. Right? They're both completely guilty of it. Not only do they gerrymander to give themselves political advantages, they gerrymander based on race, income, all kinds of different things, and no one party is innocent in that regard. And the thing is that it's not illegal. They're not actually doing anything wrong legally. All right, morally maybe they need to do a little bit of checking, but legally they're not doing anything wrong. So that's gerrymandering, and like I said, we're going to revisit this next week as part of our discussion. So you guys are going to do a little bit of investigating into this particular topic and hopefully have a good discussion about it. All right, guys, that's it for today. Good luck on your quiz tomorrow. Hope you do well. Have a great day.